Okay, so today we're going to look at practice B, which is average acceleration. And all the problems in practice B, again, have to do with average acceleration. Now, by definition, the average acceleration is equal to the change in velocity over the change in time. And what we learned is delta change in means the final minus the initial. And then usually in most of the physics problems, delta t is usually an elapsed time. It's the time interval. Now if we look at the units, velocity is measured in meters per second. Time is measured in seconds. So if we look at the unit, a meter per second divided by a second is a meter per second times 1 over a second, which is a meter per second squared, which is the unit for acceleration. Now because acceleration is a vector, it can be positive or negative. Okay. Now we could take the same equation and rearrange it. So a lot of times you'll see in your book this equation looks like VF is equal to VI plus AT, which is the same as A is equal to VF minus VI over T. Okay, it's all the same thing. So usually you would memorize it in this form. Okay. All right, so first we're going to look at number 3 on the homework. Now again, just like last night, we can do our homework out of order. So we're going to do 3, then we're going to do 5, and then after that, we're going to, you only have 3 more to do yourself. All right, so for number 3, again, we're always going to write our given, then we're going to write our find. So it says, with an average acceleration, so remember, we chunk the problem. We don't just read the whole thing and get confused. As we read something, we write it down. So it says, with an average acceleration of negative 1.2 meters per second squared, so A is equal to negative 1.2 meters per second squared. How long? So when it says how long, that means that we want to find the time. Will it take a cyclist to bring a bicycle with an initial velocity of 6.5 meters per second? So the initial velocity, remember in physics we use subscripts. So V subscript I means the initial velocity. It's 6.5 meters per second. To a complete stop. Now this is the part sometimes we have to be careful of. In physics we can read a word, but it means something mathematically. So when it says it comes to a stop, that means the final velocity is 0. So we have to remember sometimes in physics, if it says that it comes to a stop, that means the final velocity is 0. If it says it starts from rest, that means the initial velocity is 0. So these are just things sometimes when we read it, we have to be aware that that means something. Okay. Now, later on in the chapter, the way we're going to do this is we're going to write down what we're given, A, VI, VF, what we want to find T, and then we'll say, well, which equation has these 4 variables? For our homework and the practice problem, we're using the same equation, so it's actually easier. So first I'll write down my basic equation. VF is equal to VI plus AT. I want to solve for T, so I'm going to rearrange the equation to solve for the unknown in terms of the known. So VF minus VI, I subtracted this, is equal to AT, and then I'll go ahead and do one more algebra step. VF minus VI over A is equal to T. So then I divided both sides by T. Now I'm going to substitute in my values. So 0 minus 6.5 meters per second divided by negative 1.2 meters per second squared. Now why do I bother to put those units in? Let me just put my final unit at the end. Well, in physics, again, we have a foolproof way to check our work every time we do it. Okay? So when I do 6.5 divided by 1.2, Now I know what this unit's supposed to be. This is time, and I know time is measured in seconds. But I want to make sure that this comes out. So what I'm going to do on the side is, I'm going to take my units. I have a meter per second divided by a meter per second squared, which is a meter per second divided by a meter per second squared. So I have a meter per second times a second squared over a meter. So everyone look up. Look at my units. This meter cancels with that. This cancels with one of those, and I end up with seconds. Is seconds my correct unit for time? It is. So I say, oh, I did make a mistake. So you have a foolproof way to do it. And then the negative in the numerator cancels with the negative in the denominator, so I end up with a positive value. And then 6.5 divided by 1.2 comes out to be 5.4. So that's my answer. So, again, if you do it like this is a step-by-step, systematic way, you'll never have a problem and say, well, I don't know what to do. I don't know which equation to use. I don't have a way to check my work, because if you do it this way, you'll never have that issue. The more you write down on paper, the less likely you are to make a mistake. All right, let's look at number 5. Okay, well, I don't know if everyone was up to there. So number 5, that's the hardest one. It's long. So it says, suppose a treadmill has an average acceleration of. So we're going to write our given. Now we're going to write our find. It has an acceleration of 4.7 times 10 to the negative 3 meters per second squared. How much does its speed change after 5 minutes? So after 5 minutes, we want to find how the speed changes. So now I have to say to myself, these are words. So maybe it might help you to write it down, change in speed. Well, mathematically, the change in speed is going to be delta V. Remember, it's not VI, it's not VF, it's delta V, because that's the change in speed, right? Change, okay? So sometimes you try to do stuff in your head, and it's really hard to visualize, because a lot of us are conceptual and we have to see it. So if you just wrote those words, it might help you to say, oh, I want to find delta V, okay? So now, before I even go on, let me go ahead and do that, because you're saying, gosh, I only have one thing. Well, remember, first of all, this says 5 minutes, and this is meters per second squared. So first of all, I know I want to change that minute. So if I have 5 minutes, remember that when I convert, if I put this over a 1 like that, it makes it easier for my numerator and denominator. So if I have minutes in the numerator, I put minutes in the denominator, and I want to go from minutes to seconds, and there's 60 seconds in 1 minute. So this minute in the numerator cancels with that minute denominator. And I need a calculator, because 5 times 6 is 30, and then I add a 0, so this is going to be 300 seconds. Now I'm going to ask myself, well, what equation am I going to use? Well, what I can do is, because I'm finding delta V, which I know is VS minus VI, but I don't want those, I can go back up and just use the definition of acceleration. Okay, so I'm going to write my basic equation. A is equal to delta V over delta T, and this is what I want to solve for. So I'm going to rearrange the equation for the unknown in terms of the known. So delta V is 8 times T, which is 4.7 times 10 to the minus 3, times 300 seconds. Now look at my units. This second cancels with this second, and I have meters per second. Is meters per second the correct unit for velocity? Yes, it is. And you see I didn't do my unit to the side? In my work, I canceled my units, and I automatically checked it to make sure I didn't make an algebra mistake. So then when I write this out, delta V comes out to be 1.4 meters per second. All right, let's look at part B. Part B says now the treadmill's initial speed, so that's VI, is 1.7 meters per second. And it says what will its final speed be, so I want to find VF. Now, instead of doing this difficult, let's look at this. I have VI, I want to find VF, and I just found delta V. So I know that delta V is just equal to VF minus VI, and now I want to find VF. So I'm going to rearrange the equation, because when I substitute in values, sometimes I make mistakes. So I'm going to rearrange the equation and say that what I'll do is, since I want to solve for VI, since this is plus VI, this is minus, I'm going to plus this on the other side, add it. So delta V plus VI is equal to VF. So 1.4 plus 1.7, and remember the units are the same. When units are the same, I can add them. If the units are not the same, I can't add. So 1.4 plus 1.7 comes out to be 3.1 meters per second. And that's it.